Well, good afternoon. I wanted to talk to everyone about the notion of extending data centers and specifically extending the data center fabric on a global basis. Let's get that going. Okay, so imagine if you would accessing your data anywhere in the world as if it was local. Synchronizing data centers, establishing location-independent data centers where power and energy and real estate are cheap, right? Optimizing production workflows, moving terabytes in minutes rather than hours. So the whole point is to present data, global data, as global data must be location independent. So that's the whole purpose of this. So then you talk about global file systems, global storage, high-performance computing spread across sites, clustered databases where they're centralized and everyone's kind of pouring into it. Content distribution, pushing content on demand. So we talk about a fabric. So fabric, in simple terms, is a combination of storage, network, and computing resources over an optimized network. And so today, all the data and all these fabrics are contained within four walls. So one data center. So what we talk about is a fabric of fabrics. So we take that data center and connect to another data center's fabric and another data center's fabric and create a wide area-based fabric of fabrics. So then you can extend and think about taking all the high-performance computing fabric performance on a global scale. So we kind of put it in terms of where all the optimizations have gone in terms of data center fabric optimization. So a lot of effort, specifically with Seagate and the likes, have been working on SSD and optimizing and accelerating storage. So what that does is bring slow network attached storage access, and it addresses one part of the equation. Second part of the equation is the fast network, right? So then we take this 100 millisecond access times, and we're down in the microsecond access times. Then on top of that, then we have the software component to address. And then, so optimizing that, we talk about technologies like RDMA and full operating system bypass and caching and everything. And we collapse everything. But again, that's within the four walls. What we do is allow you to run your RDMA-based high-performance storage paradigms on a global basis. And this is across the city, across the state, across the country, around the world. So through data center fabric extension, we allow you to create a lossless wide area network. And their joining points with the fabric, and we extend the layer 2 advanced buffering in your fabric. So whether it's InfiniBand, whether it's converged Ethernet, whether it's DCB Ethernet, or any type of lossless fabric that's within the data center, we allow you to extend that, up to and even beyond 20,000 kilometers. So what does this do? So then your storage is in one place, so it addresses the cloud data ingest problem. It addresses the back office operation and the capabilities on a global basis. So then you can provide WAN connectivity over pretty much any wide area type network, any type of service, whether it's dynamic or static, and you run that fabric, and you dynamically allocate the capabilities of connecting these data centers. So how's this work today? So take for instance a terabyte transfer, right? Over layer 2 VPN, it would take you on the order of of 4 hours over a 10 gigabit link to transfer a 10 terabyte file. So over our fabric extension, we allow you to do it over a 10 gig connection in about 14 minutes. And then if you extend further out, distance-wise, if it's further delays, you're on the 11-hour basis. And this is on a layer 3 VPN, but it's still a 10 gigabyte connection. So what the fabric of fabrics allows you to do is, no matter where the data center is or the data you're trying to access is, you're operating on it or accessing it at the same performance level as if it was local. This is kind of a closer picture, but then this allows you to have location-independent data centers. And then on top of that, our customers use generally parallel file systems, and they then have general access over this wide area network and are accessing data, their Lustre file systems, their GPFS file systems, Hadoop file systems, all RDMA accelerated, all natively extended on a global basis. So different types of topologies. So we have cluster to cluster, where we have bandwidth to bandwidth utilization optimization. So with this approach, you're getting near 100% of the allocated bandwidth across the wide area. You can extend multiple fabrics over the same connection, and you can run native RDMA on a point-to-point basis or on a distributed network basis. So that truly gives you the location-independent data centers and allows you a full geo-diverse data center. On top of that, in terms of remote access, using the same type of technology, you can actually move the file system mount points to the enterprise from the distance-based storage. And again, it's location-independent, and you have true big data access at your computing centers with remote data. So that allows you to process in place data. It allows you to provide an optimized data ingest into your storage, and kind of works into the whole operational workflow. So like I said, we worked with a number of specific file systems, though to our solution, it's actually a transparent extension of the fabric. So we work with Seagate today on their SDA product, and what that allows you to do now is to have multiple concurrent fabrics running at different security levels or different communities of interest, and you then virtualize your whole wide area all the way to the access point with a secure paradigm in the storage domain. So as far as workflow goes, everything's storage based, right? So you acquire video, and this is a video workflow. You acquire, you store, you ship for editing, you store, you're editing, you store, you store for distribution, you distribute, and then you archive, right? All this is storage based with a multi-tenant type storage solution like the SDA. You can do multi-site whole video workflow with solutions like this. For intelligence gathering, it's the same thing. Acquire, store, ship for processing, analyze, store, store for distribution, store for archiving. And it's all over a geodiverse set of resources. So our solutions today, like I said, it's kind of WAN oriented. So we have our M series that is meant to sit on Ethernet type services, E-line, ELAN, layer 2 VPN services. our G series sits on native optical connections. And then coming soon, we have our fabric extension platform, which is a multi-terabyte storage platform for global distribution and global access. And that's what I had to come talk today about. Any questions?
Anybody have any questions for Jerry?
I appreciate your time.
Oh, come on, one question.
One
I'll
question.
give you an extra ticket. See, look, that's not a question.
What was that?
I'm giving those out now.
Yeah.
You supply the optimal I/O band,
Uh-huh.
and actually, but the I/O speed is actually limited by the real connection.
Right.
So it means that your technology can efficiently use
Use whatever you assign to it. The WAN I/O bandwidth.
Like pipeline,
Yep.
deliver the data.
Yep. In a sustained manner. Yep. Yep. So then you can deterministically use your network, allocate your network, and then with the fabric extension platform, you'll be able to dynamically assign bandwidths on a per flow basis, and a flow can run the full interface rate. But you're right. It's 100%, near 100% of the allocated bandwidth in a sustained manner. So all you're doing is, the only thing that we're not addressing is the physics of transmitting over, the optical backbone.